हेलो माय फ्रेंड्स, कैसे हो आप लोग। तो अब हम देखने जा रहे हैं एक क्वेश्चन है जो इसमें 2019 में पूछा गया था। वो है प्रोडक्शन ऑफ ड्राई आइस। ठीक है, तो ये रिसेंट में पूछा गया था, तो हम इसको देख लेते हैं कि ये ड्राई आइस क्या होती है और ड्राई आइस को हम लोग कैसे बनाते हैं। ठीक है, सो व्हाट इज ड्राई आइस एंड हाउ ड्राई आइस इज मेड। ओके, तो basically, what is dry ice? So, dry ice is also a kind of ice, but it upon cooling it does not convert into liquid, and it directly sublimates into gas. Okay, so that is why it is termed as dry ice, and it produce very high cooling effect, and up to a temperature of minus 73 degree, minus 78.3 degree Celsius. ठीक है, it produces this much low temperature. So, how dry ice is manufactured? So, first of all, what happens? The CO2 gas is compressed to a very high pressure, up to 60 bar. Okay, so you see there is a compressor attached. So, what happens? First of all, the CO2 gas is compressed in this compressor up to a pressure of about 60 bar. ठीक है, and then this gas is transferred through a condenser, and it converted into liquid. Okay, liquid CO2. And for cooling, we use water. We use liquid water for liquefying this CO2 gas. And after liquefaction of this CO2 gas, it is passed through an expansion valve, and it is converted to solid CO2. So, okay, so at point after passing through an expansion valve, it is comes at point 4, and then we get solid CO2. Okay, so this is a systematic diagram of the equipment. So we mainly have components like compressor, condenser, and an expansion valve. Okay, so this is a pH chart of the steps which are performed in a manufacture of dry ice. So you see point one is the point at which CO2 gas is and starts, and point 2 is the point at which the CO2 gas is compressed up to a pressure of 60 bar. Then what happens? This CO2 gas is passed through a condenser, and it condenses into a at point 3 we get liquid CO2, and then this liquid CO2 is expanded through an expansion valve up to point 4. Okay, so at point 4 you get a mixture of solid CO2 and gaseous CO2 and gas CO2. Okay, so this solid CO2 is separated to point 0.5, and this gaseous CO2 is moved to point 0.6, and at point 0.6 this gaseous CO2 is mixed with external CO2, and then the system reaches again at point 1. Okay, so this is the temperature minus 78.3 degrees Celsius that is reached by the help of this solid CO2. Okay, so this is how the solid CO2 basically generated. Okay, and then where we use this solid CO2 and why we use, so solid CO2 is used because it is non-toxic and non-corrosive. Okay, and that's why it is very much used in food items. Okay, and then what happens, it can be easily handled and cut, and the most important advantage of this solid CO2 is that it does not turns into liquid upon melting. It directly sublimates to gas. Okay, and one more advantage is that the triple point temperature of CO2 gas is minus 56.6 degrees Celsius at 5.178 bar. Okay, and at atmospheric pressure, so a solid CO2 can be sublimates into gas. Okay, so and it cannot be converted into liquid. So what I want to tell you, so suppose this is a curve. Okay, so this is a PT curve, and those who have studied thermodynamics, they know it well. So this is point O, and this is suppose point A, this is point B, and this is point C. So the triple point of CO2 is 5.78. Okay, it is 5.178, and the pressure at which this CO2 is used is 1.03. So this point, so up so means above 5.178 only it converts into liquid to only it goes to this process, this change from liquid to gas. So if something is below this temperature, so it directly changed from solid to gas. Okay, so this is the advantage. Its triple point is much above the triple point at which we work. So so there is no problem of conversion of this gas into liquid. Okay, I think I am clear. So this is very much advantage of using solid CO2. Okay, so but there are few disadvantages also. The first is that very high power consumption is required in this production of solid CO2. Okay, so you see about 330 kilowatt power is required for 1 ton of solid CO2 production. And also there is one disadvantage, that formation of solid snow in the expansion wall. So you see, like when this expansion takes place from point 3 to point 4, there is the formation of solid snow. Okay, so there is the formation of this solid snow, which hampers the flow of this liquid CO2 through this valve. Okay, so these are the two disadvantages. So how we can overcome, what is the solution to overcome this disadvantage? The first is the multi-stage compression. Okay, so you can reduce this high power consumption by the use of multi-stage compression, and mainly three stages compression is used. Okay, and in order to reduce the second disadvantage, what you can use, the partial expansion. So instead of directly expanding in just one step, what you can do, you can make it a partial expansion. Okay, so you first expand it up to point 10, then you cool it, convert it into liquid, then you again expand it up to point 12, then you again convert it into liquid, and then you again expand it up to point 14. So this is the way by which you can reduce the solid snow formation in the expansion wall. Okay, so I hope you liked this dry ice formation video. Okay, thank you very much. If you like it, then you can please like and subscribe, and if you have any question, you can comment in the comment box. Thank you.